Consolidation. This one, most of you know Paul Hart. He's given several presentations at RadioActivity over the past several years. He knows more about tubes. As somebody said, he probably forgot more overnight than you will ever know in your life about tubes. And he's done some really great historical work. He's going to talk today about manufacture of tubes in the United States after the war until the end of production here in the States. And another thing, if you were here last night, you saw that we had a Hickok tube tester that belongs to the club available for people to use. Paul restored that and is selling it to the club at a reduced price so we can make it available at sales like this. So thank you, Paul, for doing that. With no further ado, I present you Paul Hart.
Randy left me the pointer, so we're in good shape. Hello. Is this working okay? All right, good. This was originally portrayed to be just a history of the vacuum tube production in the United States after World War II. As I got into this, the pattern of what I was going to talk about changed. And I think you're going to see why early on. The manufacture of vacuum tubes obviously is done to make electronics equipment work. And that process doesn't go on in a vacuum. Anyway, seriously, if tubes are going to be made and used, there's going to be equipment that needs them, and the equipment that needs them is going to be made by companies that make electronics equipment and so on. And there was a lot going on in that aspect of things that most people then and now are not aware of. And I want to start this off by actually talking about this topic first. The invention of the transistor certainly ultimately was the demise of vacuum tubes. But it didn't need to be the destruction of the U.S. consumer electronics industry. And that's what we're going to start with. So go ahead to the next slide. In the beginning, this is a perspective of how all this got started, written by AT&T at divestiture to go through the history of the Bell system. And these are bullet points from the paper that is included in that historical statement written by AT&T. Even before World War I, the patent situation with vacuum tubes, everybody was working on them, and everybody had patents, and they were fighting about who got to use what patents, what was valid, what wasn't. And it had already become very complex. And during the war, many new patents were developed and shared because of the wartime. Everybody just used everybody else's patents. At the end of the war, chaos in licensing and use of myriad patents from multiple holders. If you wanted to make vacuum tubes, you didn't know who to go to, what patents what you needed. And so they said some remedy was needed if the art was to be reduced to practice. The remedy was to develop a patent pool. And at the request of the U.S. government, GTE, AT&T entered into a cross-licensing agreement effective July 1st, 1920. Westinghouse and RCA were added. RCA had taken over the assets of the Marconi Company in the United States, and most people are very well aware of that piece of history. And they actually divided up the markets. AT&T, through Western, would manufacture equipment for telecommunications. GE and Westinghouse would manufacture equipment that was to be sold by RCA. Westinghouse also got all the railroad stuff, but we know about that. And the purpose of all this was to free radio development from disastrous litigation. and thus assure the public of access to the best technical methods. Go ahead to the next one. There is a lot that can be said about this, and this is very basic. The patent scheme matured and was exploited by RCA, and Brian Bellinger has written a number of articles, one of them in 1998, that gives details of how that patent pool worked. And initially, the license fee was 7.5% of the sale price of radios, and that included the cabinets, which had nothing to do with RCA's patents. They finally got that resolved later. After World War II, Zenith President Eugene McDonald stopped royalty payments on radio tubes, filed suit charging RCA and others with conspiracy. Because RCA was manufacturing radios, they had all the patents, and everybody else who made tubes and wanted to manufacture radios had to pay RCA royalties. Not only that, RCA engineers, if you bought patents, the right to use the patents, there were like 15,000 patents in that pool. If you needed one of them, you had to buy the whole bucket. So not only that, if your company like Zenith was doing research and developing patentable stuff, those patents went into the pool, and RCA engineers had the right to be in your lab and see what your engineers were doing. This is nuts. Anyway, McDonald got completely fed up with this and just stopped royalty payments. After a worldwide series of complex actions, and I don't have a P in there, RCA settled with Zenith in September of 1957. Zenith won, but it was a Pyrrhic victory. In 1958, RCA pleaded no contest to antitrust violation. Hazeltine was sort of a small parallel to RCA in this regard. They had about 500 patents, and they threatened Zenith. Courts dismissed that suit. So Zenith proceeded to market color television sets initially with better success than RCA, and Sarnoff was furious because this cost him about $35 million a year of just gravy money. Next slide, please. Is this why Zenith bought Roland? This is what we wonder. Ironically, the guy from Zenith who was part of the process says that RCA accused them of buying Roland so they could make sure they could get tubes if they got cut off. This is one of my tubes, which is a Roland, and the tube was made by General Electric, bought in by RCA of all people, who also printed the box, and was marketed as a Roland tube. So how all this comes down is very interesting, but Roland was a producer of picture tubes, and I'm not sure they ever made a receiving vacuum tube, and it's very unusual to see a Roland box tube. So anyway, go ahead. He said they were accused of doing that to prevent losing vacuum tube supply. He did not say in the write-up whether or not it was true or not. Go ahead, next one. So, RCA's lucrative patent licensing scheme was facing destruction. RCA and others provided technical support and advice on organization of the Japanese electronics industry in return for paying to license the RCA patents. So, Sarnoff established a technical center in Tokyo modeled after the Princeton RCA laboratories. The Ministry of International Trade and Industry in Japan organized a consumer electronics industry plus financing of about 10 companies, and you will know Mitsubishi, Toshiba, Hitachi, all the ones you know. And the use of, they organized an industry to manufacture vacuum tubes using the Keiretsu organizational structure common in Japan. And that's another story in itself. But then they used predatory dumping practices to sell this equipment into the United States. Go ahead to the next one. The Japanese action initially was hardly noticed in the US. Nobody was paying any attention to what they were doing over there. And from 1958 to 1965, by selling at reduced prices in the US, they reduced the US radio industry to a shambles. In the 1960s, color TV was exploding. Zenith was leading in production and customer acceptance. And Japan attacked the US color TV market. And the Sony Trinitron and all of that stuff is part of that story. The US government refused to protect US interests. And you can go through the legal proceedings, and it's absolutely astonishing and galling the extent to which the US government ignored the pleas of US industry to protect them from this predatory practice. In 1978, the Zenith Transoceanic 7000 was the last American-made radio in production. Ironically, in 1986, RCA was sold to GE. And there's a little bit more about that later. In 1995, Zenith sold controlling interest in the company to LG Electronics. And in 1999, LG was the sole owner. Philips also acquired many historic US named companies, Sylvania, all that, to this day. And there's a whole story about how Philips became the RCA of Europe. Did you know that Philips bought all of Mullard in 1927? So all the stuff we see from Blackburn and all the stuff that was done in the 50s and 60s, that company was owned by Philips. And still, what the remainder of it still is. Go ahead, next one. Okay, so now I've gone through the first part. Now this was originally going to be about tubes. Now we'll talk about tubes and the manufacturing of them in the U.S. At the end of World War II, the total production in 1945 was 139 million tubes compared to 108 million in 1940. And the surprise of that is that you'd think World War II would have created more of a bump in that. But of course, the civilian demand went down and it was replaced by military. After the war, of course, the wartime contracts went into deep decline. And these were the heydays, though, of the American telecommunications industry. Major traditional suppliers were Arcturus, Kenrad, GE, National Union, Hytron, Tungsol, Raytheon, Westinghouse, Sylvania, and RCA. And many had built new factories financed by the government, not economical after the war. Lots of different industries in the U.S. went through that process where the company didn't have the money to build it, the government built it, or gave them the money to build it, they built it, and then after the war, or they leased it back to them to operate, and then after the war they would either buy it or sell it. So the pent-up demands after the war kept demand high. The contract cancellations and pricing pressures required gradual shakeout of facilities. And this is an example of this is the special situation of the variable time fuse, which used the patented tubes developed by Sylvania and Applied Physics Laboratory of Johns Hopkins. And everybody wonders why we don't see those tubes. And I just think when you fire a shell, the tube has got to last for 5 seconds. And those tubes had a maximum life of 5 hours. That you could test them and see that they last that long. But You know, this is not going to be a tube that's going to find wide recognition in the consumer electronics industry. Okay, next tube.
Paul,
Yes.
Can you make sure your mic is turned on?
I thought it was. Hello, 1, 2.
Hold it closer.
Sorry about that. I get into my subject. I'm sorry. Everybody wants to know about Western Electric, so I start off with the special case of Western Electric. In 1944, and if you want detailed information, I can tell you where I got this data. Western produced 1,540,000 tubes. They subcontracted almost as many. The military services ordered 3395 from other manufacturers built to Western designs. A perfect example was the 6AK5. It developed in World War II as an IF amplifier for radar systems, and at the time was a milestone. By the end of the 1970s, except for some specialized tubes, development work was minimal. In 1974, Western Electric produced 1,200,000 tubes. And on December 31st, 83, by court order, the Bell system ceased to exist. And that was an important milestone for me too, because I had gone to DC to the Telecommunications Association to work the divestiture from their perspective. The last manufacturing facility in Kansas City closed in 1988. The last tube produced was the magnificent 300B audio triode, and that is Bernie Major's quote. So I didn't say that, he did. But then he made them. Okay, next. All right, now we got to talk about the invention of the transistor. It was not an accident. AT&T had determined pre-war that in 1937 studies by the evolving telephone system would be untenable with vacuum tubes. The failure rates were going to be such that they just could not maintain the system as they expected it to grow. So they had said early on, we got to do something. And Western Electric said, in essence, we can't make them any more reliable than they are. It's just impossible. So 3 fundamental researchers, Bratton, Barnett, and Shockley, were brought together to develop a vacuum tube replacement. These guys were all throughout the Western Electric's and Bell labs during World War II, developing radar and detection systems and all that. The transistor was invented in 1947. It was announced to the public in 48. And the transistor made phase out of the vacuum tube inevitable, but not necessarily the demise of the U.S. electronics industry. That might have happened anyway, but all the stuff that I was telling you about to start with triggered that into a real decline. Go ahead then, next one. This is a recreation of the original transistor. And it's ironic, the management of Bell Labs got presented with the data on the gain of the unit, and they weren't sure they were happy with this, and they said, can you make it oscillate? So they said, oh, I guess we can do that. So they made it oscillate, and then the management was happy that it really did have some gain and could do things on its own. You know, I worked at ITT Federal Laboratories, and I can tell you some other stories like that, but that's another issue. Anyway, this is a photograph of the 3 of these guys in the September 1948 electronics, and they called it the revolutionary amplifier. The crystal triode is what they called it. And these guys were awarded the Nobel Prize in 1956. Go ahead. This is just a bad photograph. In June 30th, 1948, the press conference demonstrating the transistor to the public. They waited for all that time to be absolutely sure that they could reproduce this thing. They knew it was real. They knew it was going to work. And so it was never, this was the first time the public was made aware of it. Go ahead, the next one. Now this will give you some perspective, and you're going to see this slide a couple of more times during this presentation. This is a plot of the U.S. vacuum tube production from 1944 to 1978. And you can see that the peak year was 1955. Almost 500 million vacuum tubes were manufactured during that year. And so now you can look at the 1,500,000 tubes that Western Electric made, and this gives you some perspective on why Western Electric tubes are rare, sought after, and unusual. But anyway, this also shows the spike due to television in need and how closely the OEM numbers followed the total, which was, and all the difference is export, military, all the other, and the replacement markets. So those are the factors that are involved in the differences here. Ironically, in 1966, because of color television, another peak occurred of almost 450 million tubes in a year for color television sets. And so this curve gives you an indication. And of course, by the time you get to 76 and 78, you're getting down to pretty small numbers. And I do not have any numbers past that. But these are pretty good, well-researched numbers. The researchers that got these were there during that time. Go ahead and do the next one. Resumption of commercial demand. The MR program, this is maintenance and repair, during the war provided some tubes to the domestic market. If you pick up a tube and it says MR on it, you know it was produced during that time period, because at that time vacuum tubes were considered critical material, and it was illegal to sell them to the public. So they made a provision that allowed manufacturers to do some of this. They had to first satisfy pent-up demand created by wartime shortages. New tube designs specifically were made to address the circuit demands of new and evolving TV requirements. The 6BG6 in 1946, which was essentially an 807 with an octal base on it, and the 6CD6 in November 49 was one of the first tubes that was a new design specifically for television. Remember the current defined filaments with odd voltage ratings for series string operations, all the 4EH7s and all that stuff. In many cases, traditional types were upgraded to increase capabilities, including controlled warm-up time for the series ones. Go ahead, the next one. This is a strange case of a 6CD6. This is a photograph that will give you an idea. It's actually two tubes. It's actually two complete tubes, two cathodes, two sets of grids, all around one plate. Sylvania manufactured this thing from about 1951 to at least 1953. I've got a number of examples of this tube. I never realized it until I started sticking my nose in some of this stuff to do this. I had a bunch of these and didn't even realize it. Now, why they did it that way, I don't know, but that's just one of the curious things you find out in the evolution of the tube business. Go ahead. You know, I did the code work on Sylvania, and I've got a lot of Sylvania material. Sylvania at the same time had a very, very active communications department that tried to put information out to especially its distributors. In 1959, this was Sylvania Publicity. They had 7 tube manufacturers location. As a matter of fact, Mill Hall, Pennsylvania was the first place they made the VT fuse tubes. That had been a creamery, and they bought that and set that up just to do that. You guys who are interested in tubes and are paying attention to them, this is the improved 6SM7 GTA. You notice the old style pinch here, and they changed the design to the button base with much shorter leads, heavier leads, and by doing that, they increased its plate dissipation of the 6SN7 from 5 watts to 7.5 watts, just by virtue of being able to conduct that heat down through the pins into the socket. Go ahead, next one. They did the same thing with the 5U4, and they told everybody about it. Here's a picture of the old style pinch, the button base, the new envelope as compared to the old G. And here's the 6CD6. By this time they had ditched that goofy construction. And here's the button base on that with the old style, and this is the improved version of the 6CD6. So this kind of stuff was going on, and they were obviously as well coming out with new specific tubes for television, 6BL7s for the vertical circuitry and all that good stuff. Go ahead, next one.
What did I do?
You need to go, you're going back, you need to go, nope, back one more, there you go. Here's this again.
Ah, that's what.
And so what I'm just trying to show you is in the 54, 55, this was the heyday here where they were doing all these things, coming out with all these new tubes. Go ahead, next one. All right, now the manufacturers, after this, they could see the writing on the wall because already transistors were starting to make an inroads. And I don't know how many of you guys were in engineering circles of the time. We'd sit around endlessly arguing about whether or not transistors will ever replace vacuum tubes. No, they're never going to be able to handle high power. No, they're never going to work at high frequency. And of course, we know where all that went. National Union, 1954. This is the year I believe National Union quit. They were a major tube manufacturer exiting from World War II. The Lansdale, Pennsylvania tube plant was built during the war as a government lease facility, and it was subsequently purchased by, I've got NU over there, it was purchased by Philco. After the war, it was converted to receiving tube production. Lansdale was purchased by Philco in 47. Last confirmed date I've ever seen on an NU tube is 1954, but I don't have any specific information that that's when it was. So these are photographs of the boxes. Go ahead, Dave. 1955 was the highest production year. By 1955, transistors had begun to be adopted where low power and reliable were essential for issues where cost was not a major issue, and you know what all that means. Military and high reliability manufacturing stuff. Diverse views on when transistors would begin to replace tubes and consumer products. By 1966, solid state had not been commercialized as fast as many experts had expected. Exiting and consolidation had begun, and this is a major factor in that book that I used as a lot of resource for this, because it was a continuous situation where everybody said, well, transistors are going to take over in 2 years, 5 years, and it never happened, and then it's 2 years, 5 years, and it never happened. So this kept the tube manufacturers all unsure of what they ought to do. So the deal was, when do we get out? How do we get out? What do we do? And that story is one that these people that did this research consider one of the best examples of how to milk an old industry as it's dying and make money doing it. And they did, and we'll see how. Go ahead. GE built an entirely new factory in 1956. 110,000 square foot factory on Hartford Road in Kentucky to expand tube manufacturing. In 1970, GE opened a factory in Singapore making miniature tube mounts. The Japanese were already starting to make major inroads, And the GE explanation was change from tubes to transistors, increase of imported TV sets, because the imported TV sets came with Japanese tubes in them. They didn't buy them from US manufacturers, and significant use of imported tubes in the US, and everybody has seen the boxes and all that stuff. Go ahead, next one. Sylvania positioned itself for long-term production of vacuum tubes. They built in 1958 a brand new manufacturing facility, and this was one of the reasons that GTE bought Sylvania, because Sylvania said, we are in this until the end, whenever that is. They never made runs of less than about 10,000 tubes at a time in this plant. Anyway, it was built as a commitment to efficient mass production. The Emporium facility was their original facility, and they kept that for short run tubes and specials. And not only that, Emporium actually manufactured tube manufacturing equipment and sold it to other tube manufacturers. And that's not a very well-known thing. GTE acquired Sylvania in 1959, and the reason was basically that Sylvania didn't have enough money to build a new picture tube plant. But that's another whole story. So go ahead to the next slide. Now, when you're in the manufacturing business and you make tubes and you make television sets, you've got a whole network of distributors and service stations. And if you sell a guy a television set and 2 years down the road it has a bad tube and it needs replaced and you can't give him the tube, you're in trouble. So this is a picture right out of the date code stuff. It's a perfect example of two tubes made by Sylvania, one branded Philco, one branded Zenith. But these equipment manufacturers, when they went out of business making tubes, they had to have an alternate supply. They had to have the ability to put their brand name on tubes to keep the myth alive. So they had to, many of them had tube facilities. They had been doing this PBR, this private brand replacement tube business for a long time. And they didn't want to damage their the value of their name by discontinuing the supply of tubes. RCA had a particular problem because they were making the new Vista and they were making 60 types of tubes that nobody else made. And I don't know what some of those were, but there were 60 of them, and we'll talk about that in a little bit. Go ahead, next one. In 1961, GE closed Scranton, moved its assets to Owensboro, closed Anniston, Alabama, introduced the Compactron. RCA closed Indianapolis, Sylvania closed Mill Hall, Pennsylvania, and Shawnee, Oklahoma. Shawnee, Oklahoma had only been in business for 10 years. CBS exited vacuum tube manufacturing as well as TV. Philco exited the tube and television manufacturing. Ford bought the Lansdale plant to build car radios. And I want to tell you, the last tube you'll see out of Lansdale was dated 1961. I can imagine when Ford saw that they were manufacturing tubes, they said, that's the end of that. Next one. Raytheon quit in 1963. They consolidated receiving tube manufacturer in Newton, Massachusetts. Shortly after, they divested their manufacturing business and sold the equipment in Europe. They contracted with Nippon Electric to provide fast-moving replacement tubes branded Raytheon. And there's the kind of boxes you've certainly seen. Go ahead, next one. In 1966, only four major manufacturers remained: RCA, General Electric, GTE Sylvania, Westinghouse, and Amperex, that, by the way, had been bought by Philips in 1955. And that was not well known or publicized. Philips liked to do their stuff out of the limelight. GE and GTE Sylvania had continued significant investment in modern mass production facilities. Raytheon, Hytron, CBS, Philco had quit manufacture Tungsol was merged into Wagner Electric, and I have a Wagner Electric military contract 6550 tube labeled Tungsol dated 1975. So there was all kinds of goofy stuff going on during those years. Only Raytheon and Philco continued to merchandise tubes under their own brand. Go ahead, next one. So here now you're seeing what's happening in these years. The demand for tubes is dropping very, very sharply. Go ahead, next one. 1967, majority of radios and phonographs have been converted to solid state. Westinghouse discontinued the cell tubes and sold tubes under its own brand. Taiwan tube plant sold to Union Electric. I got one of the last Union Electric tubes made in a box that says Union Electric, and it's a POS, if you know what that means. And Taiwan tube plant was sold to GTE Sylvania in '75, and subsequently abandoned those assets once they found out what they had. It was on a barge, and they dumped it in the Pacific Ocean. Quite literally. Next slide. Okay. This is the EIA, the Electronics Industries Association. By 1967, marketing of Japanese receiving tubes was in full force. EIA started litigation in the Treasury Department, and Japanese capacity was estimated at $200 million a year. The Treasury Department took no action to dismiss the EI complaint in 1969. Next slide. Okay, 69, transistors are coming up. Premium value, high fidelity tube demand continued. Randy, that's you. Steady demand for military and industrial tubes. Reading the Altoona newspaper when the military would throw out a contract for 39,000 6X4s, it actually made the local newspaper because everybody had to go to work now for a while longer. RCA completed shutdown of Cincinnati. GTE Sylvania closed its Burlington, Iowa receiving tube plant. Usable tube making assets were transferred to Altoona. Majors announced price increases. Next slide. 1970, RCA closed Woodbridge, New Jersey, and Cowansville, Quebec receiving plant tube plants. Only the old Harrison, New Jersey plant remained in operating. The plant had not been upgraded. Its operation required extensive hand assembly procedures, and they were way past Sylvania and GE in the ability to make tubes economically. In 1973, a niche market shortage developed in Japan due to shortages of audio tubes. That's an interesting comment. And of course, the microprocessor in 1974. Last hybrid TV receiver was sold in 1974. 1974, GE closed the Tell City, Indiana plant, which had been a World War II branch factory, mothballed the Hartford Road plant. Instead of divesting themselves of it, they mothballed it so they didn't have to write it off right away. Go ahead, next. Amperex in '75 had been acquired in Philips. You see all of these various Amperex labeled tubes, some made in England, some made in Heerlen in the Netherlands, some made in the US. They continued a lot of that. They showed this, they had 4 locations: Hicksville, Long Island, Slatersville, Rhode Island, Cranston, Rhode Island. Anyway, it was obvious they were transitioning to the manufacture of solid state. It's likely, and this I'm not sure of, but I believe that they closed the Hicksville plant when they stopped making tubes in the US. Go ahead. RCA finally quit in April of 1976. The Harrison facility dated back to Edison and was a 24 building complex covering 650,000 square feet. RCA had been trying to figure out how to get out of the tube business as early as 1971. GTE and Sylvania purchased 10% of the tube equipment, the right to produce Nuvistors, and 60 unique receiving tube designs, because RCA still had to have those tubes So they sold that capability, and they then got their tubes back from Altoona. The new Vista assets were moved to Emporium. The 60 special type assets were moved to Altoona. And when you think about the end of all tube manufacturing, it was 3% of the company's value. Go ahead, next one. Post RCA departure, GE restarted manufacture of metal tubes. It had to have been military demand, but they were previously manufactured by Kenrad, but when RCA went out of business, there wasn't anybody making them anymore. And you can see them, if you know how to identify them, you can see some of them as they come up. GTE worked the purchased assets into its operations. 90% of its tubes were made in Altoona, specials and short runs in Emporium. In 1978, RCA finally sold off its retained inventory, but remained in the tube resale business until at least 1985. And for whatever it's worth, one of these days I'm going to be able to publish the date codes on RCA tubes all the way to the end in 1985. Only Nippon Electric and Matsushita remained as Japanese importers and sellers. Go ahead, next one. Absent from the Harrigan study is any information on the Europeans. And we all know about the Mullard Blackburn factory. Philips was importing tubes from Heerlen, the Netherlands, marketed in the US as Bugle Boy and World Logo under the Empress brand, and here's that World logo. Telefunken was making tubes in Berlin and Ulm factories. This tube is a weirdo, and Randy, when we're done with this, I want to show you this tube. I don't know if you've ever seen one of these, but when you look at it, it's branded, it's identified as a 12AX7. You look at it and you say, oh, they got it marked wrong. It's a 12AT7. No, it's a 12AX. It is, and it was made in a Siemens factory in East Germany. And I've got copies of this tube labeled Amperex and Mullard and one other brand. And I've got this tube. I brought it so I could show it to you.
Quick question on that. I guess you know that when they went to the Russian factories, they started using the Halo, not the Halo, the flying saucer type getters.
Okay.
Be indicative of that.
Okay. At any rate, these were probably in the late 70s, made in East Germany, in a factory that the Germans tell us was operated by Siemens.
So a real German factory, not a Russian.
Yeah, yeah. Okay, next slide. Supply attempts in the decline. You've seen these boxes too. And it was started, as far as I know, by ITT as a resale. And most of these tubes are either high quality Japanese or American tubes. And then Lindahl. The distributor in Patuxent that I am aware of claims to have seen and distributed some of the tubes labeled in RTT boxes, but I've never seen one. And so you get tube caddies full of these things. Go ahead, next one. Whoop. Okay, the Wild West of audio tubes, and you know about this. This is the demand for premium audio tubes continued because there was a lot of golden ear people that wanted their KT88, yeah, there's Randy, responding premium audio tubes, and provided a golden opportunity for counterfeiters. An extreme example is shown below. I actually have 3 of these. This is a KT88. It says Jolita Tube Factory, made in China. And I believe it was made by Shuguang. I don't think there was a Jolita Tube Factory, was there? I don't think so either. And here is a duplicate of the same tube. It says made in England, Amperex, 6550, industrial tube. This is the kind of crap that went on continuously for years until all this got sorted out. I keep things like this around just to show people who don't believe it. Go ahead, next slide. 1980 to 1988, Phillips bought GTE in Williamsport, Emporium, and Altoona. Final tubes were produced in 1988. Altoona closed in August. Delayed the use of Phillips' name on commercial products. They did it on the military tubes more than on the commercial ones. They continued to use the yellow Sylvania name and print for quite a while. They wanted the ECG plant in Williamsport. It was actually a facility that bought parts from everywhere and distributed them. And they got away with this and continued this for many years. You'll see all kinds of ECG boxes with parts. Go ahead, next one. General Electric and MPD. GE merged with RCA in '86. A condition was to divest the Vidicon production at Owensboro. GE decided we're going to get rid of this whole place and just sold it to an investor group which took ownership January 1st, 1987. New company was Microwave Products Division, and that's what they called it, even though it was a corporation on its own. MPD continued to manufacture some tubes, mainly audio tubes, well into 1993. The last ceremonial run of the 6550A was on June 17th, 1993. Next one. This is an example of that tube that I have in my possession. I displayed this at a MAARC meeting about 10 years ago in Davidsonville. This is the end of tube manufacture in the United States and basically the end of my presentation. The point is that there is a tube company in business in northern Georgia that's named Western Electric. And they recently sent out a list of, they said, what tubes would you like us to make? And of course I said, you ought to figure out how to make a Russian KT-120. That is a real tube. So in the meantime, the Russians have gotten to the point where they are making tubes that in many ways are as good as any tubes we ever made in the United States. And I think I've had some firsthand experience regunning amplifiers with KT-120s. It is a fantastic tube. It's one of those it just seems to be just right. And so it'll be interesting. They want to do the 300B triode, and we'll see how well that works. Yes?
Hey, is Western Electric still around as a company, or did they sell their name?
The company in Georgia they've, in one way or another, they've gotten the right to use the name Western Electric, but it's not the same company.
Yeah, that's what I thought.
But it's completely committed to vacuum tube production. Yes, Randy?
Wonderful presentation. Your attention to detail is to be applauded. Which leads me to two things, a question and maybe a request. You mentioned several times here about audio tubes, quality audio tubes, and we saw last night's tube auction that these tubes that people consider to be premium quality could really be expensive. And you kind of intimated that in your presentation. Is there any reasoning behind that? Or would you be looking into doing a presentation where you're comparing, why audio tubes are so much more valuable than your regular run-of-the-mill version of the same tube?
My experience generally is that there isn't that much difference. It's a very, I don't know if the audio people remember Vacuum Tube Valley. And they did a lot of blind comparisons and all kinds of things, the 12AX7, the EL34, the 7591. And I think a lot of those were flawed because they were just plugging tubes in and they were operating under different conditions. My personal attitude is I don't think there is that much difference, but the main difference in price is the perception of the quality. On the other hand, the Telefunken 12AX7 really is something special. because RCA had commissioned a research program to find out what was in the tele tube and how RCA could duplicate it. And their finding was, we don't know and we can't do it. So the magic of the Telefunken 12AX7 probably died with the guys who knew how to make it.
Yeah, I know there was a variant called the 803S,
Yeah,
which was a frame grid, very similar to the 6DJ8. But
and we didn't even talk about frame grid tubes here, the 6DJ8 and a lot of these later tubes that, like this, what is it, 7788 pentode that has a GM of 50,000. I mean, there were a lot of really, really exotic tubes. Yes.
Well, you mentioned it in the beginning about how the Japanese radio market, or the consumer electronics market, was ruining the American market. I read a marketing article, not directly related to radios. They said they did a similar thing with steel.
Yes.
They bought waste steel and made rebar and sold it really, really cheap. And the American steel manufacturer said, oh, let them have it, that's the low end of the market, we don't care. But then they used the money to build newer plants, and they started making high quality goods that really hurt the American industry.
Not only that, but when I got into some of the research chasing the RCA thing, they had pools in other countries. There was a pool in Canada. There was a pool in Europe. And one of the most shocking things to me, and maybe I'm a naive guy here, but the United States has antitrust laws. Just about every place else in the world, the government encourages its industries to align themselves together. And that's what the Japanese Keiretsu is. Mitsubishi has like 20 companies in it. And they're all joined with other companies under Toshiba, under Hitachi, elsewhere. And the government actually funded some of the development of that industry. Then they set their prices in Japan for radios and made their money that way and sold them lower prices than their production cost in the U.S. And that destroyed the U.S. industry. Yes.
I know the high-end audio tube makers produce, or some of them do, make 2A3s. Do you know if anybody makes 45s?
I think JJ does.
Yes. JJ does.
yeah, primarily the JJ tubes, I think they're made
In the old Czech Republic.
and they're generally considered to be absolute crap.
Oh, really?
Yeah, for their output tubes, except for the EL84, are
Okay.
considered to be reasonably good. They're kind of based on the Russian version of the EL84M, very
Yeah.
rugged tube. But the rest of them, do not touch them with a 10-foot pole. They have a tendency to be of poor quality.
I've got some 2A3s that were made by Shugwang that are pretty good.
Yeah, exactly.
Your opposite station.
I'm sorry, what?
The JJ tubes, they have a tendency to, the grid and the plate in there are not fixed very well, and they tend to, well, short circuit, and you can imagine what happens.
Yeah,
if
right,
like,
Especially-
your output transformer doesn't like that.
Especially in a triode when the grid hasn't got much else place to go.
It's a reliability issue with them, not.
Yeah,
Well-
definitely reliability with the JJ, exactly what he was saying, the output tubes and shorting.
Yeah.
And your higher end tube dealers
Well-
will not sell them.
The letter
Yeah.
J, the letter J.
Their customer support's quite nasty too.
Well,
They'll
let's-
send you a broken tube. You go and you call them up and you say, hey, this tube failed immediately. Call them up. They send you another tube. That one blows up. They'll call them and say,
Well,
hey,
you're
we sent you
making the
two
case
tubes."
for a lack of reliability. Do you have something else?
Yeah, it's, JJ is the letter J, and the letter J is.
Yeah.
Yeah.
Okay.
Yeah, and what I was just doing some internet work, and they are claiming that they can't now get the quality of glass they need to make the tubes they want to make. And of course, it goes without saying that all the distributors of these tubes in the U.S. now, made in the Saratov plant in Russia, have been cut off. And there is desperation in the audio business about where we're going to get tubes. So all of your 6550s are now more valuable than they have been, we believe. Yes.
Okay,
That's,
Dave, you got those tubes?
I bet you the Western Electric plant in Georgia is happy about that.
Well, they weren't happy with me telling them to build a Russian KT-120.
They have a website.
Yeah.
On the website is a comments little box you can fill in.
Yeah,
So I
that's
asked,
where the
they
survey is.
specifically asked for what tubes can we make. So I answered it and I told them, well, you ought to get into the vintage radio tube replacement.
You don't need, look, remember the chart? 500 million tubes a year, and you see the boxes of tubes that showed up out here? They're going to keep showing up. Those tubes are still out there, a lot of them. But what I tell people, 1L6 is, if you need to have a good tube tester, see, to make sure you don't throw away any good tubes. That's another story. Randy,
Where can we get one?
see me after the discussion. Yeah, Randy, you had another?
Yeah, I was just going to add an anecdote that I've had experience with about 10 years ago, and that was I had a Mac 30, and I was working on it, had it upside down, and after a couple of minutes of it running, I looked at it, and one of the 5881s, because I had those tubes in there, was glowing red. So I didn't realize at the time, I thought maybe the tube had gone bad. That was a tongue saw. Pulled it out, and it was running at least a couple of minutes, red plating. Put in a Russian version, Saratov, turned it on, kept an eye on it. After about 30 seconds, it started red plating. I realized, I probably lost bias someplace, and indeed I had. Fixed the bias, turned it back over. The Russian was kaput, would not work. Put in, I figured the tongue saw was cracked. Put it in, no problem.
Absolutely, and that's,
Reliability and ruggedness,
that's-
two different things.
well, the 5881 was the precursor to the 6550.
Okay.
And so you just told the story of that tube and tongue saw, and as far as I know, Wagner Electric continued to, under the name of Wagner Electric, they continued to do tubes. I think we are out of time. I appreciate your attention very much. Thank you kindly.